Hey guys, what's going on? Today we're going to work on multiplying binomials, but real quick, watch the do now as we distribute the 2 into the x plus 5. Quite an easy math move. 2 times x is 2x, and then 2 times 5 is 10. So if we go into the next one, it's 3x is going to go into both. Now remind yourself that when you multiply x by x, you get x squared because we add the exponents. And then minus 15x here. So that is going to be that. All right, so the first method I'm going to teach you is called the box method. Basically, it works like this. We're going to multiply 2x plus 3 by x plus 5, a binomial times another binomial. So you put the first binomial on the top, so 2x, and then that positive 3 goes here. And then this is x and a positive 5 or x plus 5, however you want to look at it there. Let me use different colors so you can see how this works. In each box, you just multiply the edges of the box, like the area of that box. Area is length times width. So 2x times x would be 2x squared. This box is a 3 by x, so that's 3 times x. This rectangle's area is going to be 2x times 5. That's going to be 10x. And this last box is a 3 by 5, so that's going to have an area of 15. And what we end up doing is we end up taking these corner pieces and we add them since they're like terms. So what happens is we have our 2x squared comes down. Then we're going to have our 13x is our middle term. And then we're going to have our 15 at the end. Notice how I combined it so that it's in standard form and there's no more like terms. This method is the same as what's called double distributing. So we're going to write that in here. It's called double distributing. All right. So what we want to do next is teach you how to do this double distributing without the box. Now, some kids prefer the box, which is awesome, so keep using the box method. But eventually you want to try to, after you've done this enough times, not use the box method because double distributing is pretty quick, and I think you'll get the hang of it when you practice. It looks like this. So the 2x has to distribute into both terms. So we're going to do that first. 2x times x is 2x squared. So we'll write that over here, 2x squared. And then 2x times 5 is 10x, positive 10x. And the next thing we want to do is we want to distribute this 3 in, so I'll go underneath it just to show you that you can also multiply the 3 in to both terms. So 3 times x is 3x, and then 3 times 5 is 15. And what we notice is that there are like terms here and here. These are like terms that can be combined. So what we're going to do is we're going to add them. So the 2x squared comes down. 10x and 3x is 13x. And the 15 comes down. And what you notice is it's the same answer that we got before without using the box. So in order to do this properly, you want to use the distributive property. So we're going to put the word distributive here. You might hear teachers say or myself say double distribute because you have to distribute both numbers in, so you distribute twice. So multiply each term in the first set of parentheses by each term in the second set of parentheses, and then add exponents of like bases. And at the end, the last thing you want to do is combine like terms. All right, so let's do some practice problems together on the next page here. All right, so the first one, we have x plus 8 times x plus 6. Now, you notice right away that this is a binomial times a binomial, so we are going to double distribute. So I'm going to distribute in the x to both terms. What that looks like is x times x is x squared. X times 6 is 6x. And then I need to distribute in the 8. So I'm going to distribute in the 8 to both terms, and that's going to give me 8 times x is 8x, and 8 times 6 is 48. And then what we notice is the like terms here in the middle, the 6x with the 8x, And so our final answer will come down as x squared plus, now 6 plus 8 is 14, so 14x, and then plus 48. And these are not like terms, x squared, x, and then there's no variable, so those are not like terms. Now you might say, okay, what if I want to use the box method? Well, let me show you one more time the box method. So you make your box, kind of looks something like this. All right. And what we do is we write each part of the binomial up here. So this is x minus 1, and this is x plus 7. And so this is a very nice way to organize your work. So x times x is x squared. X times negative 1 is negative 1x. X times positive 7 is 7x. And negative 1 times 7 is negative 7. And we always have these like terms right here in the middle. So we're going to add up everything accordingly. So x squared comes down. 7x minus 1x is 6x. And then that minus 7 comes down. So you can get your answer that way as well. All right, let's keep moving. We have this one here. I'm going to double distribute the 2x in. So that's going to be 2x times x is 2x squared. And then 2x times 3 is 6x. And then we're going to multiply the negative 5 in. So negative 5x and then minus 15. And if I combine these like terms here, we are going to get our final answer of, these are like terms right here and right here. So we're going to get 2x squared plus 1x minus 15 at the end. All right, so let's keep doing some practice problems here. I'm going to move on to number 4. So let's go ahead and do number 4 together. What's x times x? We get x squared. What's x times 4? We get 4x. And then I also have to distribute in this negative 11. So that's going to be negative 11x minus 44, because 11 times 4 is 44. And as always, in the middle, we have what are called like terms. So I need to combine those like terms, and my final answer is x squared. 4 minus 11 is negative 7. And then the 44 comes at the end there. All right, I'm going to do the next one with the box method, just to keep mixing it up so you guys can see that this works both ways. So we make our rectangle box, and we are going to put each binomial here. So this is x plus 9, and this is x minus 2. And we are going to find the area of each box. So this area is x times x is x squared. A 9 by x box would give us 9x. A negative 2 by x is negative 2x. And this is negative 18. And what do you notice in the middle is you will have these like terms on the diagonal here. So we're going to go ahead and combine those. So we're going to bring it down so it's in standard form. X squared, negative 2 plus 9 is 7, so 7x, and then minus 18. And this is an alternative way as opposed to double distributing, so that works as well very nicely. All right, let's go the traditional way of just double distributing here. 3x times x is 3x squared, and 3x times negative 2 is negative 6x. And then we are going to come in with our other distributive of the 1. 1 times x is 1x, and 1 times negative 2 is negative 2. We have our like terms always in the middle when we do it like this, as long as the original polynomials are in standard form. So we have 3x squared minus 5x minus 2 as a final answer here. All right, let's keep moving through some different types of examples. Now, the next few are going to get a little harder, so pay attention, and then there's going to be even some special ones in here as well. So let's jump on to this one. Now, you might say this doesn't look like double distributing, but it really is, and here's why it is. You have to notice that this exponent of 2 actually means to multiply whatever it is by itself. So this is really b plus 7 times b plus 7. And now you can easily recognize that as a double distributing. So b times b is b squared. B times 7 is 7b. 7 times b is 7b. And 7 times 7 is 49. And again, get those like terms. So my final answer is b squared. Let's write that a little better. B squared plus 14b plus 49. And so that is how we do that one. Now you might say number 8, this looks a little different as well. And you're right, it has multiple variables. So we have x's and y's, but it's still a binomial times a binomial. So it's important to realize our strategy has no reason to change. So with this one, I'll use the box method just to kind of keep letting you know. You can always use the box method. Box method always works nicely. So let's make our box. And what we're going to have is on the top, it's going to be, let's change colors so it's easy to see, 3x plus y. And on the side, it's going to be 2x plus 2y. And that will be our boxes. So now let's multiply in. 3x times 2x is 6x squared. 6x squared. And then we have 2x times y is 2xy. And 3x times 2y is 6xy. And then at the back end, we have 2y squared. Now you'll notice again, these are like terms. So we're going to combine our like terms for our final answer. So it's 6x squared. And then what do we get here? So we have the 6x squared plus the 8xy plus 2y squared. Side note, standard form doesn't apply here really because we're dealing with multiple variables. So just do it in the order that you get it. All right, look at number 9. Again, you might say, I don't see two binomials, but you have to realize this square means something very, very important. When you see that square, you're going to want to write this out 2 times. So it's actually 3x plus 1, minus 1, excuse me, times 3x squared minus 1. Now I'm just going to double distribute just traditionally. So this I'm going to distribute in the 3x squared first. 3x squared times 3x squared is 9x to the 4th. Why? Because I have to add the exponents. 2 plus 2 is 4. And 3x squared minus times negative 1 is negative 3x squared. And then I'm going to distribute in the negative 1. So I get negative 3x squared. And negative 1 times negative 1 is positive 1. And what you will notice, as I keep saying, is in the middle here, you're going to have like terms. So let's combine those up. And our final answer will be 9x to the 4th minus 6x squared, and then that plus 1 at the back. All right, so the last case that I want to look at with you today is if the binomials are what we call conjugates. I'm just going to write that word here, conjugates. Not that you have to remember that word for today's lesson, but when you see the binomials are the same, but with opposite signs, one has an x minus 3, one has an x plus 3, it's important to realize something is going to happen when we double distribute. So watch what happens. So x times x and x times 3. That's going to be x squared plus 3x. Now let's multiply in the negative 3. Negative 3x times negative 9. Now what do you notice about these like terms here in the middle? Well, the like terms are inverses. They're additive inverses. They're opposites. And opposites always add to what? Opposites always add to 0. So x squared, 3x minus 3x, they actually cancel each other out in this case. And so we just get x squared minus 9. So let's show another one. I'll do this one with the box method just to show you that it really does work if you like this box method. So we'll make our little box. We have our x plus 5, our first binomial, and our x minus 5, our second binomial. x squared. This is 5 times x. This down here is negative 5 times x. And this is negative 5 times 5. And again, what do you notice about this and this? Well, they're like terms, so we were tempted to add them together, but if you look very closely, they're opposites, so they actually cancel each other out. They add to 0, so we get x squared and then minus 25, and that is the final answer here. All right, let's do one more together, and here we go. I'm going to just traditionally just like double distribute this in. That's going to give me 49x squared. Again, the x squared is because x times x, you add the exponents. 7x times 4 is 28x. And then I'm going to distribute in this negative 4 into both terms. So I get negative 28x. And then lastly, negative 16. And again, what do you notice about these middle terms? They are like terms. But it's very important to realize that they're going to cancel out. So if they cancel each other out, they're opposites. One has a plus sign, one has a minus sign. That's very important. That's when you have opposites. So you get the 49x squared minus 16 as our final answer. Okay, thank you for watching, and talk to you later.